Good evening. Okay, shall we get the show on the road? Very much, Tom. Well, it's great about a chatty crowd. So, brilliant. And thank you all for coming here this evening to be speckled. So I'm Mike Beaven, and I'm a group leader and transitioning to global automation leader for Arup. And so I come from an engineering background, and it's good to see old friends and colleagues and erstwhile colleagues in the audience. It's good to see you. So, you know, in terms of our history of computing, you know, I too have stories of coding on Deck 10's 3D stuff. I have a very, very old beard. But it's about this new generation of collaboration, of working together. As you'll know, one of the Arup strap line is we shape a better world. And this evening is really about people using computers to shape a better world. And it's a really exciting place to be. It's moving so fast and the development is so rapid. And Speckle for us is a key part of that. So it's a long term. We're in this for the long haul. We have been tapping our keyboards for a long time. And I think this sort of new way of working is what we're here to talk about. Rob Greig is our CIO. He was saying a few words in a few minutes. And so to Speckle. We've got Dimitrie in part of it, which is absolutely marvellous. And there's a bit of a sort of catchphrase, you know, what's the question? The answer is Speckle. But we are finding it really useful. It's not the answer for everything. We have other challenges which not the answer. But we are finding it really, really useful and incredibly powerful for really two categories of work. Our projects, obviously fundamental to we do projects. It's our entire reason for being. We have lovely clients who employ us to do fantastic projects, generally. And we want to do them as well as we can and as collaboratively as we can. And the projects are really harnessing the power of Speckle as a data platform, as a connector, as a translator, to make what we do much more collaborative and much more, well, almost instantaneous in terms of how we collaborate with our work colleagues, our architects and other people. So it's transforming, it's a transformatory mechanism for how we do our projects. It's also part of our sort of future, for our automation future, how we automate really complicated multidisciplinary workflows and how we get them to work smoothly together. And so the other part of it is a mechanism to connect. So as we start to do workflows that do connect lots of different things together, we're finding Speckle is a very powerful part of our arsenal, as I'm sure you are, in how this happens. So, you know, I think this is a first day of a community, or a meeting of the community for going forward. I do, of course, have a duty to perform, the compulsory health and safety announcement. So I'll tell you the best news that the bar's out until 10 o'clock. We normally finish at 7, so that's a pretty good deal. I wonder there's a coincidence there. So we have the toilets are across by the back of the bar, so you can visit the bar and go to the toilet. It's great. And there are no alarms planned for this evening. So if there is one, orderly leaving the building, and there'll be people that you can follow to get to the mustering point, which is actually on Fitzroy Square for those that know the area. So without further ado, I'd like to ask Rob to come and say a few words as our CRO. So do enjoy this evening. There's lots of fantastic and interesting people here. Have a great time and learn lots about Speckle from your friends and collaborators. Thank you very much.
Thanks, Mike. I think Mike understates himself. He's been tirelessly working behind the scenes on automation at Arup for the last 12, 18 months, Mike? Something like that. So Speckle's all of a sudden become a really special thing, and the question is, you know, what's the problem? Can Speckle solve it? And I was disappointed to discover that my problem of the day is I've got squirrels living in my loft, and Speckle does not solve that. So it's let me down already, Dimitrie. Sorry. But I think that, so I've not always worked in the AEC sector, the architectural engineering consultancy. industry. I've worked in the arts, I've worked in public sector, and digital transformation has been the name of the day for a long time now, and I categorize that in three areas. First, what I call digital housekeeping. So digital housekeeping is knowing where your stuff is, your data, is understanding your risks, dealing with your legacy, and improving efficiency, and understanding the skills gaps in your organization. So I would call that step one. Step two is shamelessly stolen from the government digital service, which is build things so good that people want to use them and make stuff work. And both in terms of skills and people having a greater understanding of digital and technology, but also building tools that work for people and people want to use them. And then step three, the final step, is add value, add value, add value. And Speckle absolutely cross-cuts all three of those things. It's been a real gem for us to find a tool, a platform, a thing. We'll explain more about it later, won't we? A thing that integrates different things together. And there's a fundamental challenge within our business. And that fundamental challenge is we work in a niche. And that niche is full of incredibly smart people. And some of those people are in this room today, and I am privileged to be stood here in front of you all. You know a lot more about this business than I do. And we do very niche things: structural analysis and design, architecture, infrastructure, buildings, rail, energy, sustainability. You know, the list goes on and on and on. But what that means is the tools that get developed for us by third parties are very expensive. And it's virtually a duopoly these days. There are two big players in this space, and every year they put the prices up by at least 20%, often more. And it's a huge challenge for us as a business, and I think it's a huge challenge for us, it's a huge challenge for those who are sometimes our competitors, sometimes our partners in this space. And we are now having to find ways to diversify, be creative, and move laterally into a space where we can offset some of these huge cost challenges coming from these big platforms and create a competitive space. And one of the things I firmly believe is open source is one of the ways we can do that. I'm a huge fan of open source software. I'm a huge fan of the open source community, both open data and open source software. I also quite like open hardware as well, but that's just more of a hobby than the serious venture at the moment. But probably has a role to play in IoT, actually, going forward. And so I think this is potentially one of the ways that we can manage some of the upward cost pressures on our business from a software and procurement perspective, and also create a community of like-minded individuals that want to make a difference and really drive benefit for our clients and for ourselves and the work we do. And so the last thing I want to say about Speckle before I kind of hand off is Arup has some very strong firm set values that have been around since the 1970s. Some of you are familiar with Arup, may have heard of the key speech by Arup, and it talks about things like social responsibility, straight and honourable dealings, being a humane organisation, and it also talks about quality. And we often look at some of these tools and we go, oh, how much money can Speckle save us through automation, effectively? You know, can we reduce the number of times a human being has to interact with something and spend hours doing something? Yes, of course it does. But I think the real value that it brings is the quality. It maintains the high quality that we need in an environment where, if you just look at the modelling, I was looking at the Guggenheim stuff, which we did in LA. I think that had to be split into 4 models because it was so big. Something like that, because these things are becoming so big and complex in the built environment, they're kind of becoming unmanageable. So we have to come up with new and creative ways to keep these models working together and connecting together in a way that they maintain their accuracy and maintain their quality. And I think we've been incredibly fortunate to find Dimitrie. I have no idea why, when you were doing your PhD, you decided to do this, Dimitrie.
It's a long story.
But I'm really pleased you did. I think it's a remarkable piece of software that you've developed. And I'm also really pleased that you chose to open source that software. And I am doubly pleased you chose to come and work for Arup. It's great to have you on the team. And I'd just like to thank everybody that put this event together today and organised it. It's not an easy thing to do. And I would also like to thank all of you for taking time out of your valuable evenings, we don't have many before Christmas, to come here and either contribute, listen, partake, debate about how we can get some more open source into the built environment and doing positive things for the work that we do. So without further ado, I'm handed over. Thank you very much.
Thank you. This was a very humbling introduction. We have to work on our elevator pitch a bit more, but we're going to try me and Matteo, who has to come up here. Sorry, Matteo. We're going to do a quick introduction because I expect most of you know about Speckle a bit, no? I guess.
Raise your hands if you used it. Okay.
Okay, cool. That's a good show of hands. For those who didn't, there's no shame. It's Rob was very enthusiastic about the quality of Speckle and so on. We're less enthusiastic about it, mostly because we're at the receiving end of all the bug reports and things that don't work. But this is our distorted worldview. Anyway, it's just 2 slides, so it's not. It's also like maybe 240 pages long thesis, but I won't bore you with that. Essentially, for those of you who haven't used Speckle before, it's a bit like Flux, if that's something you know of. It's essentially kind of a neutral connector in between various software. It's got various clients embedded into things like GSA, Dynamo, Rhino, Grasshopper, the usual suspects. We're developing a few more quite slowly. It's a different topic. And technically behind it, it's a very simple thing, right? It's not rocket science. Huh? We're just applying kind of standard industry practices from the software development world, and we're trying to make them usable in the AEC world. So most of the value of Speckle, it's in essentially bridging this impedance mismatch in between what AEC wants to do and what software development already does since quite a while. Right, and now I'm handing over to Matteo, because what we're going to do is a very fast roundup of stuff that happened in the Speckle world that you might not have seen or know of. And it starts with the Revit client.
Yeah, so a few slides on the clients and some of the updates on the clients. Here we're showing the Revit client. If you don't know, it's been released in beta, so it's part of the installer. You can download and try it out. Here we're showing that we added selection filters. So when you create a sender and you want to send geometry, you can filter by category, by selection, even by properties and view. So you can see here how we are selecting elements by a parameter, for instance, and all the objects that have that parameter with a specific value. So you see how you can specify an operator. If a family name contains pile cap in this case, all the pile caps will be selected. So this is just to give more control over what is being sent and how. And if you want more information about the Revit client, just visit the documentation online. Here is a screenshot of the Excel client that Mish is going to present in his speech. This is not being released just yet. It's not part of the installer, but he might mention how to try it out. And it's great. You can see the shiny UI, so it's pretty cool. This is the Blender client, which is not really new. It's been around for about a year. It's been developed by Tom. For all the Blender users out there, check it out on GitHub. It's ready to be used, and it works well. Here, just a slide to show updates on the web UI that Dimitrie's been working on. Some great new stuff, as you can see, versioning and history of streams, a lot more control on the stream, so what you can do from the web UI itself. The web viewer also received a ton of love, so there's been performance in the improvements in the performance in features, so you can now select by, you can query objects, you can color them by different parameters, and query them, and a lot of other cool stuff. So check it out both on the web viewer and from the docs. Next.
Yes.
A bunch of other features?
Yes. A bunch of other random stuff that happens from the community, right? So this is in case, is anyone programming in Go here? No. Does anyone want to program in Go here? Well, I do. Cool, yeah, good. So we now have Antoine, actually, who, he developed a Speckle Go client. So if you want to hack applications around in Go, you have a starting point where to start from. Then also we have a nice Python SDK. So actually I know there's probably a lot of Python users out there. Hello Giovanni, welcome. You're a bit late. Okay. So we do have a quite well-developed and kind of tested Python SDK for Speckle essentially, which helps you scaffold whatever Python script you might have or Python-based applications to talk with essentially the Speckle API and all the rest. And it's been developed by essentially Tom originally to be used in the Blender client. Then Antoine came in and did the documentation, and also Izzy contributed as far as I know. And Izzy's going to talk more this evening, sorry. And yes, wonderful stuff for the developers out there. Yes, finally. So if you're developing applications based on in .NET and using Speckle, we are now pushing out continuously NuGet packages. So instead of actually downloading the whole thing, cloning it up and so on and so forth, you can just reference a package with NuGet as should be proper. Yes, then on the server side, right, there's been a couple of updates and magickery happening. The most important part and the most kind of visible part for the companies that you're coming from probably is that now authentication is modularized and you can integrate it with Active Directory or Auth0, which then you can integrate Auth0 itself with many other things, or with GitHub. And of course, there's also the good old email and password authentication system. But if probably you're running on some sort of Microsoft service, do look at how you can do it with Active Directory. There are some documentation online, yes, which actually we've been accused that we don't have documentation, so that's why we actually made a slide that we actually have documentation to prove you wrong, all you naysayers. It's mostly been written by Mish, then we've started adding on it, then we started, anyway, it's there.
If there's something missing, just point it out and we'll...
Yes, and actually documentation has this really nice edit link here, so if you spot mistakes, that's going to send you to the GitHub repository of the website itself directly into edit mode of that specific file, so you can already fix those mistakes and help us out, right? We're not spell checking very often in here. Anyway, but yes, and then now a shout out to pretty much all the contributors that Speckle has had throughout time, more or less. I hope I managed to get everyone in here. This is the Hall of Fame of Speckle, right? And as you can see, Matteo insisted on having 3 pro tags on his GitHub account. In truth, he has none, but that's a different topic. Okay, and now, yeah, so probably you've seen this on Twitter. It's going to be,
I think there's some delay.
Ah, there you go, sorry. It's light speed has been reduced. Anyway, so we're going to have 9 talks in what follows, essentially, and they're kind of all squeezed together with this schedule that you can see online. We're going to have a break in the middle during which food will come out, so in case you're nippy and hungry, we will feed you. Drinks are already outside. Feel free to step out and grab another drink if you're thirsty, as you want, right? So it should be a relaxed evening. I think that's it. Next one, we're going to invite Tom Bunn to present Arup Carbon. I'm going to put the thing on.
Thank you.
That was. Yeah, just
Cool. There we go. So yeah, I need to caveat this by first of all saying that I'm not a developer. I'm more of a kind of champion for this particular tool that we've built within Arup. Also to echo Rob's point, I thought I'd mention where Speckle hasn't solved a problem for me, which is timesheets. If you could get Speckle to do my timesheets for me, I'd be really happy. So Arup Carbon, or Arup Carbon Tools, or tool as we're currently calling it, is a tool for doing kind of embodied carbon calculations through Speckle from building information models. Sorry, my notes have come. So my first experience with Speckle was seeing Dimitrie talk, I think just after you joined Arup, about the wonders of Speckle and all the good things it could do, and sharing Rhino models between architects who could play around geometries and kind of be doing things simultaneously. And as a mechanical engineer who doesn't do too much geometry manipulation, I kind of went, oh, so what does that mean for me? What does that do? And then I saw, it wasn't me, but a couple of other people who couldn't be here tonight helped develop this tool. I went, that's great. I can see the benefit of mapping this data and taking it and putting it to something else, and particularly for client engagement. So our big thing with our carbon is doing a fairly straightforward calculation, but it's making embodied carbon visible, because we have a real problem in our industry that all projects in the AEC industry have a negative impact on our environment. Right? So making that visible to people, making people understand, that's really important, and is emerging as a field certainly within engineering. So Arup itself has signed a whole heap of climate declarations. I gave this talk a couple of weeks ago to some of our directors, and these are the three that we thought were really important and how this relates to those, and embodied carbon tools generally, which is helping us to collaborate with our clients, helping us accelerate the shift towards low carbon in our work, and to minimise the wasteful use of resource in our design in both quantum and detail. And that last one's about kind of not just about the resource itself and kind of building a concrete building, but the resource in getting to a solution, which I think this helps us get much quicker too. In a similar vein, Arup's written a document called A Better Way, which those of you internally will have seen. It's another one of our kind of propaganda things that says Arup is not a cult, we're a good engineering firm. And these are two key paragraphs, that about our contribution and how we need to get better in all of our work, but also how digital technology is going to enable us to be more sustainable. And here's a screenshot of the tool itself. I've got a video in a second, but I thought I'd put in a couple of screenshots in case that video fails, which happens quite a lot. So the tool is built through Speckle Viewer, and again, I'm not a developer, so I'll let Dimitrie maybe speak about the details at some point. But once you've pulled it through from whichever software you're using, you can then visualize where the materials are used in your project, and it gives you a nice graphical output of where your A1 to 5 carbon, for those of you who know the RICS method for embodied carbon, sits within your building. So from this is an example in King's Cross that we're currently designing in my team, where you can see that the steelwork for the structure on top has the most significant impact. And so we can take that to an architect or a structure engineer or a client and go, look, this is where we're currently at. Here are where the opportunities are to reduce your embodied carbon, and we can get it down and finally report that. And it also gives you a nice kind of, it might not be too clear on the projectors here, but it gives us some nice summaries in kind of Speckle JSON format, so we can then pick this up and use it elsewhere as well. So if we want to start chaining these tools together, there's a nice, that's what I really like about Speckle actually, is the ability to kind of pick up data from one place and put it in another. Then once we've got this result, we can use it and place it elsewhere. We can either report it through our Revit models, or we can put it into other tools. This is my really, again, non-developer simplified diagram of how it currently works. So you have a building information model that exists on your server somewhere. You decide to push that to Speckle through a Speckle stream. We're currently mapping against the University of Bath's embodied carbon data sets, and it says, right, that is a concrete slab, therefore it has an embodied carbon factor of this, and it just does a large summation over all your building elements to produce this report. So again, a fairly simple calculation. This is the video. And it's going to work, yes. This was just, Dimitrie pulled this together, which has been really valuable in getting people to adopt the tool, that just shows how it works. So you guys saw the Revit client earlier, and you can create a stream called Really Cool Structural Model. You can select all the elements, in this case a structural model, but it can take facades and architecture and whatever else, because it's Speckle and takes any object. You can stream that through, and you get your Speckle ID, and you can jump into your Speckle, and we've got a separate landing page for carbon. And you can start generating this report through the viewer. So we put the stream in, we put a cost against the project, we filtered down by Speckle type, and so it gives us columns, walls, slabs, beams, whatever. We can apply a material against that. Unfortunately, Arup's Revit models don't map well against the IC database. It's a bit of a manual task at the moment. You've got to go through and go, okay, that's that. But it gives you a nice way of going, okay, the purple ones are that, and I know it's the right thing that I'm putting in, and you can check against it. With A1 to 5 carbon, you've got to put transport details as well, so it gives you some standard factors, or you can put in your own custom ones if you know more about your site. And it generates this nice report, and you can go back and go, actually, that's not concrete, that's timber, that's, you know, whatever else. I want to make the report look better. And eventually, it spits out this. Let it run for a second. There we go, and you can kind of filter down and go, that's where the carbon is, and there's a link to methodology we're using. You can give it a name, and you can tag people like Graham, who's here tonight, and say, Graham, there's a report for you. He'll pick it up in his Speckle projects, and can go view it. And and so we can send this URL to architects and clients and whoever else we want. We can pick it up in a review. They don't need to have Revit installed or Rhino on the machine or any other visualization software. They just need to have the link and a connection to the internet. And we can then talk around, you know, where the carbon is, what the project is currently doing, and how we can make it better. This again was a slide just to make sure that I had something to talk about if the video didn't work. One thing that skipped over in that video is the ability to then create heat maps within that tool with carbon as well. So you not only see where the materials are, but where your worst offenders are. And because the slabs here take up the most volume, they're highlighted in pink, and the blue elements as a total amount of kilograms of CO2 equivalent are in blue. And you can move those sliders to kind of filter out the view of the project and start attacking different bits and pieces. So what we're finding with the tool itself, we are one of many tools that are looking at embodied carbon assessments. I think at my last count we had about 20 competitors within the industry. We're not too worried about that. There's very few that are doing this kind of nice 3D visualization, if any. Lots are focusing on how to graph that information in Power BI, whereas we think we have a real kind of interesting slant on things there where we can kind of spin a model around and see it in real life. Non-modelled elements have a significant impact on the overall embodied carbon equivalent of our project. So we saw some structural models there, and structural engineers don't usually draw rebar until about stage 5 of a design, and therefore we can't pick that up. So Dimitrie's given us a quick hack recently to allow us to put custom volumes into the model to account for that. I think later iterations of the tool are going to find a way to neatly push that in. Embodied carbon factors vary between regions by amount, which is significant. So when this database by the ICE is set and it's updated on a regular basis, they're saying, okay, your steel is produced in the UK, and the UK has a fairly clean grid, and the energy they use to produce that steel is not too bad. Whereas if you went to use this tool in Australia, which is coal heavy, your factor would be much worse. So we might have to look at ways of getting around that and getting new data sets in. We also lack reliable benchmarks. So the RICS, the Royal Institute of Chartered Surveyors, has started putting together embodied carbon information as an open source data set. But it's not very good. There's about 200 projects in there at the moment, and we're not entirely sure how good the data is that's gone in. So there's an opportunity here, particularly with it being open source, to start developing new benchmarks. And the last one is embodied carbon is only one part of the conversation. The whole life carbon assessment is really important to get a full understanding of our projects. I'm a mechanical engineer by background. I'd really like to be able to measure embodied carbon against operational carbon of glazing units, so that we can decide whether triple glazing is a good solution or not, because we know the embodied carbon is much greater, but the operational carbon is better. So what we're aiming for, I always struggle to explain the development process of something like Speckle or Arup Carbon to engineers and architects. A project has a definite end date, and you're going to, it's going to get built, and then you're going to forget about it. Well, not forget about it, but you're going to leave it be. With this kind of stuff, it's much more iterative, and we want to start releasing updates rather than going, yeah, we're done now. We don't need to look at it again. So we're going to aim for this kind of platform agnostic solution. We're reliant on Dimitrie and others building ways to plug into other software, but we're not just a Revit client. better. So this is, again, my kind of, oh, this isn't the thing I was looking for. That's it. So this is where our kind of next phase hopefully goes, which is that Speckle node still exists. We have our building information models as we had before, but we have another method for bringing in non-model data. So Arup has a tool called PEC at the moment, which is a project embodied carbon calculator. It's an Excel sheet that gets looked after by 2 or 3 people and regularly updated, but it's still an Excel sheet that sits in a job drive somewhere. And we're going to try and elevate that into a similar tool, we think, that isn't just looking at building information models, but a line-by-line entry. We'd like to be able to include for other embodied carbon factor data sets that exist globally, and the ability to put in custom values as well. We'd like also, and it's in dotted line because it doesn't really sit in the remit of this tool, but the ability to generate insights from the projects that we've looked at and start to spot things like trends. As an industry, we said we need to be zero carbon by either 2030 or 2050, depending who you're talking to. It'd be really nice to use the output of this to say whether both Arup are walking the walk in terms of that reduction, or whether the industry is as well, and holding people to account for things like that, because there isn't much accountability when it comes to embodied carbon currently. And this is my kind of North Star, which is that whole life assessment of being able to not only include the construction information of a project, which is what we're currently doing, but the operational, the refurbishment and the demolition of a project. So we can look at this as a whole big problem that needs solving across a project rather than looking at each thing individually. And then this was a slide that I had in for our Arup leadership forum that was the other week, but I thought was relevant here, that I'd encourage those in the room who either are working on stuff or think about working on stuff about what else we could be doing with this tool to build stuff on top of it and create great platforms, both digital and sustainable. So that's me. If you would like, I was going to just plug myself a little bit and say, if you would like to hear more about this tool and you're based in London, or if you're not, I can Skype in. I'm more than happy to come and kind of give you guys a chat and kind of walk you through it. We're trying to be open source. There's a little bit of kind of, we're not sure how much we give away to other people at the moment with the Arup Carbon tool, but we can definitely show you what it is. We see it as part of our offering in terms of sustainability at Arup. We're not going to kind of give it to you guys as a product and say, now you can do sustainability for yourself, you don't need us anymore. But we're going to say, this is a great way to engage with our teams. Great. Thank you. Cheers.
Now we have a remote presentation from Gooskens from the Amsterdam office. There's going to be another pair of Dutch people presenting later on today. And I need to stop live streaming, I think. Are you doing it? Yeah, it's done?
Can you see my screen? Can you hear me?
Yes.
Hi. All the way from Amsterdam.
Cool.
You pronounced my name correctly. That was nice.
Sorry. I'm doing my best. You can start whenever you want. We also can't hear you anymore.
You can't hear me?
Now we can, so go ahead.
Okay. I'm a BIM specialist and computational designer in the Amsterdam office with an architecture background. And what I want to talk about is not so much the automation that we have in place within Arup. We call this the Global Automation Framework. This is a huge initiative to align all workflows using a global Revit standards, a data scheme that is used globally and a language that is used globally. And here and there we see Speckle pop up in workflows. But I'm working with external parties a lot as a BIM modeler, BIM manager. And what I find, even though we can specify what kind of information we want and how we want it, that it kind of clashes with our workflow. We have to manually trace or query these models for the right information all the time. And the problem is it's deeper and it's political, and I don't think it's going to change anytime soon, that we're all going to be aligned. What I want to show an example here is for this particular project we get Revit models from an architect, and they are like half a gig size, And we use them for coordination purposes, but there is a lot more information in there that we can use also to generate our analytical models. So what we want, for example, for a structural point of view is we're interested in what are these materials, what are the levels, the elevations, the depths. There's a lot of stuff you can query from this model, but you don't know how this model is structured. So sometimes I exercise and try to figure out how do they work, and try to set up a query. But how Speckle is set up is that there is a sender on one end and a receiver on the other end, and who is then here responsible, or who should take ownership of the query? And the infrastructure right now for Speckle is that the architect should send a stream of this information, but we are going to take ownership of what we're going to receive because it's going to be part of our analytical model. So I think when you want to stream, or when you want to get information from an external party, it is you that is responsible for the query. But so what I've been doing in a lot of projects is just exploring these models that we're receiving and writing queries. But this can be cumbersome and quite a maze sometimes, and I wouldn't recommend it all the time. But I want to show some examples where I've used these model queries for different file types and set up to generate new models. I'm going to start off with the same example. So as you all know, this is a Revit is a highly structured piece of software. For this project, we got Revit models from the architect, and we need to set up an analytical model. And as a little exercise, I thought, okay, can I generate a structural BIM model without doing any modeling? So, because I know the engineers were building an analytical model in their software, in this case GSA. So I just needed to link these two sources of information together and generate a well-aligned structural model. So this was I think like 7 months ago, this project where there was no Speckle Revit yet. So I built my own little query in Dynamo, and I would stream these the levels, grids, and floor outlines and some properties. And then based on the information that was coming in from GSA, I would match these two to generate an IFC model using Geometry Gym with some control over the bridge over there, some openings, positions, offsets, alignments. And then this I could stream back to Revit or export as an IFC to send to the client. So this was a little exercise. It's not a perfect workflow. If I would do it over again, I would do it way different. But this is an example of how you can use Revit data from an external party to generate something new. So yeah, this is the old viewer. It has been improved now. There is some clipping going on, but here I'm showing that what I'm generating is this structural model that is now it's coordinated with the architectural model, because that is what is the scaffolding is from the architectural model. So that is that. So the next up, PDFs. It sounds old school, but we do a lot of retrofit projects, and we still handle a lot of PDFs. And I work with them all the time, and I receive them. And what we have to do, what we can do, is you can also decompose PDFs. They're like if they're vector based. They're line objects, they're colors, there's legends, there's text objects. You can interpret that and translate that. And here there's elevations. So when you import that in Rhino, for example, you can look at the placement point of these PDFs and with some logic align these, and then match these colors to the legends. And what I would do then is generate speckle objects in 3D. So this was also a little exercise, but I can imagine if there is a client or anybody who has a stack of PDFs that are organized or structured the same way, you can generate the scaffolding of something new very quickly. So then here Speckle can be used to process a batch of PDFs. Next up, also IFCs. You can decompose into individual elements. So this is another project we're doing in Amsterdam. They're building it now. It's one of the tallest timber high-rise buildings, I think. And right now we're in the construction phase, and we're getting IFCs from the contractor on a regular basis. And IFCs is a file format that you're not supposed to decompose. Yeah, you can decompose it, but not generate something or edit the content of it. But you can decompose it into all the property sets that you see at the bottom, and you can specify what property sets or specific properties you're interested in, and then map it and generate Speckle objects again from this, because it's an open file format that you can decompose into individual line or objects. And I'm using right now the Geometry Gym IC Decompose tool. And what I was interested in, because these are openings that they want to make in this tower, and we have to check if structurally it will still be okay, and we have to design a rebar around these objects. So this needs to go into our Revit model with our own library and with some checking procedures in place. So what I do is, what you're seeing here are the center lines of these opening objects. So I'm extracting 3 center lines, and then I'm trying to identify in Revit where it's clashing, or where it's touching an object, and then generating a family instance on that point where it's happening. So this is not the most sexy example of using or decomposing an IFC, but you could do lots of things also with IFCs in combination with Speckle. And then finally, this is very similar to the PDF. We work with also science and industry partners a lot, and what I came to know is that it's not the building industry. It's a much bigger industry, actually, and the global general standard to share 3D information are still DWGs. And they're well organized, these file types still, but it's not as standardized as Revit. So there is a little mapping exercise that you have to do, but DWGs, for example, this is a project where we receive files like this on also twice a week. And when you look at it, there's all these colors that and layers that you're not seeing here right now, but in the layers there's different strings. There's a lot of information again in this model, and so also with these models I try to exercise decomposing it into something useful for our analytical models. So I'm extracting the floors, generating Speckle floors, grids, Speckle beams based on these filters and queries. And then finally generate a Revit model that is well aligned and coordinated with dummy elements, and then we send that to Tekla where it's designed, and we send it back to Revit, and then we have a model that we can share with the client. So going back to this this workflow, I think it can be improved, because what I'm doing usually, decomposing these foreign structured models, can be tedious and time consuming. And I think when you look at what we are doing, a lot of people are doing, I'm not concerned about what is happening within your magic, what everybody is doing within their organization using Speckle, because you can communicate with each other and you can tell the other person, I want this. But when you're working with external parties, it's harder to specify because of, like I said, political reasons, or they're just, it's also a risk involved when you try to specify what the information you want, or if they could set up a stream, which in turn will maybe cause conflicts in your models. So again, trying to look in these models yourself can be a pain. So I came up with and these are my my wishes. I see Dimitrie is like my dad, so I have my Speckle wishes. Some kind of Speckle or a model decomposer in the admin app would be a dream come true, I think, for a lot of people. I think a lot of this might not even be possible. But I know that, for example, IFCs and with Rhino models, you can decompose them, you can read these models probably even inside Speckle, so in the admin app where people could upload these models, and it could display the structure of these models. So the uploader on one end uploads their models, and they don't have to be concerned about what they send. But we, on the other end, the receiving end, you can specify in the admin app what you want, and then you have to set it up once, and then it streams from one side to the other if they keep their structure maintained. But this will probably also overload Speckle with all these big models, but there might be use cases here, I think. And then finally, this is something I came up with recently, is because when you want to query or you want a specific piece of information from an external party, you want to specify that and perhaps send that query to them as a request. And then I can see this happening. So this is the other way around, where you... Oh. Okay, I'm finishing up. Okay. No, okay, but I think you get the point. And this, I'm showing here an example where what if you can specify what you want, and that the architect receives a request for a stream with a specific query, and this could be a package of queries, and then he can decide to accept or decline. Okay, that was it for me. Thank you.
Yeah, that's actually quite cool. Thank you, Guus. So actually that's really good ideas, and we'll pick them up. Regarding the uploading stuff, we wanted to do stuff, actually. I'm not joking. So yeah, your wish list might not be ready by Christmas, but let's say we're on the same wavelength. Okay.
Cool.
Thank you very much for staying late and presenting. Okay.
Yeah, no problem.
Cool. So next up, it's Fernando's turn, who's also been instructed to hurry a bit, I'm afraid. It's not his fault. Yeah, take the mic. I have FRB. Wait. Sorry, we are not experts at what we're doing here, but yeah. It's good. Hey, it works. Cool.
Thank you, Dimitrie. So hello everyone. I'm Fernando from the Facade team in Arup, London. And actually haven't been long in Facade. My background is architecture, where I have much stronger background. And so I had the chance to face a bit the challenges and that both disciplines, so both sides of kind of the design and the consultant side, will face when they have to collaborate on the daily task. Also, I've heard a lot of gossip and complaints about each other, but I'm not sure about the ratio of architects and engineers here, so I'll refrain from jokes. I'll carry on. So that's a bit delay. Quite a fast delay.
Yeah, sorry. It's, there you go.
Oh, it's good to know. I'll hit the button like in the previous slide.
It's Skype for business, right? So lower your expectations.
So design is quite an exploratory process that has to be validated with analytical processes. That is what both sides of the equation that. We live today in this sort of fragmented world of digital tools. And it's quite challenging to sort of establish that collaboration, and we have more tools than ever before. They are faster, they are better, they can produce more insights. So we have more reports, more drawings, more BIM models, and the real challenge is how do we handle all that information, and how do we actually use it meaningfully? So that's kind of a bit of the enemy, of the challenge. We generate a lot of data that is a bit all over the place, and we store it in many different file types, and to be honest, like connecting that data with the people we collaborate is a bit of an intensive task. We have to extract data, duplicate models, clean them up, use them, create a new file that we send someone else, and it's not a very efficient task, and actually can get quite hard, can feel quite overwhelming to have to handle all these 1,000 pages of reports and stuff. So what are the tools that we're using? Certainly it's not, I don't know, like tools that allow you to create like 1,000 of class detection points in minutes might not be the right answer. So how can we better collaborate, and what are others doing? How can we be more effective and responsive? And it's interesting to see what other industries, other people are doing and how they collaborate. And I remember, like, I know you all remember, like we had physical software and physical copies that we had to install and wait for like a year to wait for improvements and to fix bugs and so on. And whilst now the software developer, they all collaborate in this sort of online environment with visual version control systems. I'm not a developer either. I'm not sure if I want to be. But I find this approach quite interesting as well. So this way they collaborate. I find it quite interesting. So the fact that there is a common environment, a master branch that you can deploy. So you share that environment, but it's detached from the master file or the master branch, so you can play with it without the risk of messing around, but still like with all the background that you need. Then you start working on it, and everything is sort of tracked with these commits, which you can explain why you make certain decisions, and you have a clear history of the design, well, the work you're doing, until you open a pull request when you have a certain bit of information to share. So others can comment and review, and then you get feedback, and it helps you to take it to the next level and improve it until it's ready for being tested in production, until finally is merged into this, make sure like it works with the previous code and it's merged to the master source. So what those two approaches could mean in the design environment that we are more familiar with. And so I think we are now in a more like kind of offline design environment where we are a lot of individuals and disciplines working together in different files and formats and to different speeds probably and deadlines and constraints, and we try to obviously communicate as much as we can to try to inform others' outcome, and try to also like understand what are the requirements from others to arrive to the right answers. But still quite an intensive process that requires a lot of translation, interoperability, duplication of files, etc. So on the other hand, what that online approach will be to the digital journey, let's say. So imagine like we had kind of this sort of common environment where we are all sharing this environment, and we can plug our tools to start shaping goals and constraints from a multidisciplinary perspective, and arrive to the answer from this sort of common environment. And again, like avoiding the duplication of files and overlap of information. So my case study, which is a kind of a hint to sort of try to use this sort of approach in a sort of contained piece of design, is this. So imagine you have this tension structure, rather large tension structure roof. So tension structures tend to move quite more than usual, and spectrum movements are greater than other structures, and therefore the implications on the glaze, where I'm from the facade, from the envelope design, so I'm more obviously concerned about what that skin is and the implications of that structure. So we typically will develop a series of studies to understand what are the implications of that movement into the glass and the warp. How can we ensure waterproof resilience? What are the stresses on the glass from that warp, and how can it? What are the risks of compromising the seals, etc. So rather a kind of intensive work. But now imagine that you just that the structure is actually the support of a massive water feature with jets shooting lots of water in a sort of dynamic performance around the roof. So now you have asymmetric or a unique geometry with asymmetric structure that has asymmetric and dynamic loads on it. So even more difficult. So what can possibly go wrong here? A few things. And I kind of introduce you to those sort of challenges very quickly. So again, like understanding the movements and the shear, the compression of the joints, how they open up and down, are even more important in this sort of context. So different load cases will make the structure behave in different ways. And we cannot, in this case, isolate a portion, a typical bay, because it doesn't exist. So everything is it's a bit unique, and you need to develop that very good understanding of the overall behavior. It has a dynamic loads and therefore kind of emerging behaviors, more complex and so on. So we have to address this kind of collaboratively from architecture, structure, and facades in this case. And the traditional approach will be very time-consuming. So now imagine that you can use this object, so Speckle object, kind of similar to BIM, where you can embed data, parameters that whatever you need for other consultants to carry out their job. So in this case, you can embed information about the geometry, the analysis, the optimization. You can then stream that into your collaborators' tools, almost like, so all the disciplines can plug their tools into this data stream and introduce some other additional layers of information, whether it's an optimized geometry for the structure or useful feedback on how things behave and what are the things to watch out and improve. So that's that will sort of allow this sort of workflow in which ideally there is no overlaps or duplication of information, but information will travel from the designers to the consultants that will assess that design. So structure engineer and facade will build their models based on that input. Structure and facade can also communicate themselves using this similar approach, where one can inform about what are the movements that the structure see, the other can feedback on what are the weights or the build-ups, and both can then feedback on the implication of that particular design iteration. And once this model is built, you can theoretically like iterate more and enable that sort of exploratory process to find out the right answer. So I think you mainly know Speckle. So again, you have streams of data. So you want to have a platform that allows to manage the data, so you know what it is. You can also describe what that data contains, how to use it, and potentially you can link additional documents of how it's meant to be used, and enables this sort of trackable history of the design journey where you can understand who sent data, who received, and what is a sort of activity. Plus, you can look at back at history and understand what are the changes. So a bit of more closer to that sort of version control tools that software developers use that I find interesting. You have a viewer where you can explore that data, and then you can access the not only the geometry but the data contained. And more interesting, you can use that to inform BIM models or outcomes that are shared or are kind of built collaboratively. So the architects might be building the adaptive components for the roof, but the actual build-ups or dimensions of the rafters will come from us. So we don't need to produce another model. We don't need to send lots of pages of report, calculation, etc. I mean, we can just fit into that strategy. So we have a certain more clear line of how things evolve. So that's what we were doing in this sort of example. So architects will stream information about the panels. In the video is very laggy, but pretty much it was showing a bit of more practical way how are we collaborating. And because this is not very good and we're a bit of stretch, I will just conclude saying that Speckle has been a very great asset in this sort of workflows and proves to be very, very useful. And as it was said at the beginning, it adds value in terms of it connects the different design parties much better, and so they can collaborate and communicate better. And as Mike was saying at the beginning, like our dream was to sort of shaping a better world through total design. And I think this platform definitely enables that, right? Enables that enhanced collaboration where people can connect their platforms, and also disciplines can get better connected, knowledge, people, etc. So it can only get better and on this sort of massive landscape of data. So hopefully we see more people collaborate in this environment, and we had to fight less with what is the latest file and has it been sent to the right people and so on. So thank you.
Thank you, Fernando. Fernando is Matteo and mine's favorite user, probably. Because, he produces very nice bug reports and is actually stretching Speckle quite a lot and putting it to good use. Now, next up we have, so you had so far like 2 presentations essentially showing like end user case studies, like Fernando and Guus. And next now is Tim Hoffeler Skyping in from Germany, with a different use case in which he's going to show kind of the more development side of things, which is going to show what he built, some custom applications that he built on top of Speckle. And for him to start showing stuff. And afterwards, there's food outside. So that hopefully will keep you here still, okay? I need to stop sharing this now, Matteo? Yeah.
Okay, so hello from Germany. You can hear me? Or?
Yes, we can, Tim, very well. Actually, we can't really see your presentation yet because we're... because it's laggy. Wow, this is crazy. Yeah. We're discovering new functionality in Skype for Business, so... Yeah. But there you go, your presentation is now online, so you can go ahead.
Okay, so.
Yeah.
Thank you very much, and welcome from Germany, especially from Wiesbaden, and very happy to speak about some projects we did on top of Speckle, so where we used Speckle as backbone in the background. And maybe short about me. Who am I? I'm the owner of a small software development company here based in Germany, in Wiesbaden. Studied architecture, doing some things in building smart user guides for IFC written and so on. And I'm focusing on standardization tasks and so on here, especially in the German market, classifications and how to bring manufacturer data into fantastic BIM models. So yeah, why we are here? One thing where we struggle in a lot of projects we consult is, well, the question, do we really need to put all the information into the model spec? So in this case, mostly Revit, as we have already seen in the presentations before. And so we create silos, and it's difficult to access, especially for people that are not sitting in front of the Revit desktop and have a license. So yeah, some questions we're facing is who's responsible for which data and so on, and how do we grant access to the information part of the data, and how do we provide this data in the models, especially the information, for the processes after design phase, so prefabrication, and how do we bring it to building site and stuff like that. That's one thing where we try to find an answer and used or try to follow this approach that we create an information model outside of the geometrical and proprietary information model like Revit. So you have tons of parameters and shared parameters inside of Revit, but it's difficult for people outside to access this data. Okay, we can use Excel to export and import and bring it back and merge the data, but that's maybe not the best workflow. And yeah, who's also interested in this information model? Maybe we already heard some terms like using Power BI for reporting, or bring it to the job site, the one who installs the parts, mainly in the MEP business. How can they access the data? And though the first step was this spring, we had the chance to create a booth on the ISH trade show in Frankfurt. That's the biggest MEP-related trade show. If we follow the ISH organization, it's all over Europe, the biggest one, but I don't know. It's quite huge, and they asked us to do BIM at ISH booth, where you can see this small model. So we had 5 different sections, so we tried to explain the workflow and what could be after the design phase. So if we hand over data to the prefabrication and the warehouse, if we deliver stuff to the building site and mount it, and then later on to the operation site. So for that, in the background, we used Speckle as the data storage and machine that serves everything. And it was WebSocket based approach. So one thing I will show it in shortly live is a dashboard that is connected to the Speckle streams, and we showed how to track status of parts and so on, and try to show some different approaches how probably installer on the job site can get access to the model. So my demonstration works, so it's should be live. Yeah. So we have. Hope you can see my Chrome. That's the UI of our scenario we implemented. So we have a dashboard. It's quite straightforward implemented. So we have different phases, and we have parts in the model that are in a specific status. The one thing I can show you is the check-in. So we have, go back here. And we had the prefabrication, and after that we had the warehouse check-in. So I want to deliver a part to the building site, and afterwards I want to check it out again. And so at the moment we have in the warehouse 2 parts. And if everything works well, I can show it. So we had placed some QR tags on real existing parts we got from some manufacturers and some prefabricated ducts, bands and T-pieces and so on. So we had a QR tag, and can hopefully show it here so you can see me shortly.
Oh, yeah, we can. Go on. Perfect.
Should have a QR tag, so it detected the tag, so that's in the background it's the Revit ID. And in this case I want to assign a storage space. So I have some piece of, so in this case it's a fire damper, and I want to deliver it to the warehouse and store it on a specific place. So I hit submit, and it is saved in the background into Speckle. And so the second part is, you can also, if you want to try, you can check it out. So if you go to fastbin.eu, it's still alive. So I'm now at this stage. I want to check out this part I've before stored. And in this case, we thought it would be nice if someone has a small model of the things they should mount in the next sprint or the next week. And so they want to mount the fire damper, and it also works on the mobile phone. It's responsive, and so I select my fire damper. It tells me, okay, maybe that's not so interesting to see the ID, but I know it is in the status stored, and it's stored in this place. If I go to my dashboard, it will shift the parts then to the next level. So if I want to check it out and say, okay, I'm now in installation, save it back to Speckle. And so now I shift it to the next status. And so we hand it over from one phase to the next and show the workflow of parts through the building life cycle. So if you want to check it out, it's still alive and should work. So that was our first contact with Speckle. And afterwards we got a call from a big manufacturer that creates this fantastic red-colored fire stop elements and so on, and we implemented on top of this approach some functionality for their BIM center. It's nearly the same approach we did on the ISA trade show. But some things we were not so satisfied because there was only a limited amount of time, and so we couldn't configure the parameters. That was hard-coded at the moment where we implemented the solution. We want to map it to different models. We didn't catch use cases, so how to deal with different access rights and roles and stuff like that. So for this trade show, the intention was everyone with a mobile phone could immediately participate, so we have no login, nothing, which is not a real-life scenario, of course. And how to deal with phases in the project. And so we did some research and work quite a while together with the company. It's called BIM, they have a product BIMQ, where you can define your employer information requirements in a generic, not software-related way. And another thing that's quite interesting is from a more operation-oriented organization, CFM Connect, that they have some on IFC XML-based approach to set up use cases or configurations for use cases. So you want to inspect a door, and I need these and these parameters and these object types to fulfill this job. I put it to the slides if someone's interested. Maybe you can have a look at this. So yeah, how to proceed? So Speckle was set as a machine, and we want to integrate this with want to provide the data to these different participants, and plus face use cases and employer information requirements. Though the next step is something we developed now after the trade show. It's a product called Leia, and Leia is a web-based, or more or less web-based solution. We have the possibility to configure faces in our project. So the higher the face, the more information we will have on the elements. We can show or set up use cases. So for example, a door planner only needs to see the specific geometry and elements they need for their job. So maybe a door planner is not really interested in some ductwork, pipe work, or cable trays. And so why should they see all this information? Same for window planner and so on. We did also a small use case for the provision for void planning. If someone wants to go more into detail, I showed it on a presentation on the Build Europe in Edinburgh this October, and it's recorded, so you can find the information there. We developed plugin for Revit that is able to edit the parameters, but we don't store the parameters anymore in Revit. Everything you edit is immediately pushed to Speckle in the background. So our approach is to keep the Revit model as stupid as possible. And everything is in the database, and that's controlled via our own plugin. So we have the possibilities to push and pull data and, of course, map informations. I will show it shortly afterwards. We have a plugin for Navisworks. Navisworks has a I can eat everything geometrically. It's very interesting for us because we can handle IFC and Revit, and of course can open and process. And here we also can edit the same parameters for the same door, for example, in the Navisworks model. And we wrote a small, we try to avoid Excel, but Excel is BIM tool number 1, maybe. And so we try to find a way around, and but we want to make it as a safe data entry point. As you all know, you can do nearly everything in Excel, and it's very hard to keep track of data inside. So we can edit this small app here, nearly the same way like Excel, but it's not Excel. Okay, so in the background, of course, you need to configure this stuff, so we can create cascading projects, so you can also handle, thanks to Speckle in the background, very big amount of data and projects. And on top of this, we implemented this project phase logic and the use case handling, plus the guidelines that control everything. And that's a short view to the implementation, how we did it. So we have everything running on top of Docker images and containers. So we have one big set of containers that is responsible for Speckle. Then we implemented our own .NET Core web server in front of that. Authorization also is the same as Speckle now is doing with R0. We have a Swagger API, so we can talk to our .NET service via Swagger, and what we currently implement is a OData API that serves the data, for example, for Power BI, and our plugins plus tools are using the API. So we use it also for our internal development. Yeah, so let's shortly jump to layer. So that's our web front end. So we have a project, that's a Speckle project in the background. Here you can set the faces. So for example, if we go back in the face, which will maybe not happen in a real-life project, but now for demonstration, you can see is if I select the door, I only see one parameter, and let's go to the door planner use case, for example. You can see, okay, we select based on the data in Speckle only the elements from the model the guy is interested in, who's responsible for the door planner stuff at the moment. So if I select the door, we see only one parameter. If I go back to another face in my project, I see more. So I have now drop-down lists, and I can define the opening and the type of door and so on. These data here are maintained or provided from the guidelines. So the guideline is responsible to serve the right parameters. And if we proceed to the next phase, we see even more parameters, checkboxes, stuff like that. And that's the same way for all the elements that have a guideline in the background. The same UI is our Excel replacement. So in this case, if we go to the doors or the walls, we see everything in a list, as you can see, and we can assign the same parameters. So in this case, fire rating, excuse me for the German terms here, fire rating for this door, I can add in a more or less spreadsheet-like user interface. Yeah, the same stuff is available from Revit. So if we select the door here, you can go to the edit dialog, and if I change something here, it is pushed back to Speckle, so not to the model, as I mentioned already before. And one thing maybe I should shortly show is the mapping. So if we want to push data from the model, so that's my Revit family here I've selected and all my parameters of Revit, and I can map my internal Revit structure to this more generic way of parameters coming from the guidelines, or maybe provided from the owner of the building. And we can map in both directions. So in this case, this one is going to the database, and this one is coming back from the database. And in this case, we can push in both ways. So that you can push and pull the data also together with the geometry to Speckle in the background, and make it accessible for people that are not sitting in front of the design software. That's it so far. I'm done. And
so the next one up is Matthew, who is actually typing in from Cincinnati. Am I right, Matthew?
Yeah, that's right. Is the microphone working?
Yes, we can hear you loud and clear, and we can see some emojis on the screen and stuff, and your name. So Matthew has been Matthew has been a really long time contributor to Speckle, and he's been like kind of helping us firefight various bugs and issues here and there, and adding functionality, like just easily when he saw an issue popping up, he would just fix it if he had time. Now Matthew works at Woods Bagot, and that's it, I think, from me. Matthew, it's all yours.
All right. Thanks, Dimitrie. Like you said, started contributing to Speckle back in 2017. I was interested in it for a personal project, but quickly got drawn into what Speckle was and have been working on it here and there ever since. So thanks again to Dimitrie for having me at this meetup and for creating a really open and positive community around Speckle. I'm excited to be here. So today I'm probably going to be giving the least sexy talk. I'm going to be talking about the admin page of the Speckle admin plugin. So we're calling the talk today Speckle Admin Admin. And I don't think
Cool.
for the name of the roots, okay? So what does Speckle Admin do? It allows you to manage users, projects, and streams on your Speckle server. So on the nav bar on the left side, if a user has admin privileges, they'll see this little tab, which will take you to the Speckle Admin page, Speckle Admin Admin page. So who gets to use it? By default, the first user that's created when you spin up a Speckle server will have admin privileges. Is a flag you can set in your Speckle server environment file if you'd prefer that not to be the case, but that's the way it typically begins. And then within the Speckle admin panel, you can edit users to give them access as admin. So here we're going to make Jane an admin. I'm assuming these videos are loading, but let me know if they're not.
They work fine, Matthew.
Okay, great. Yeah, and so we can give Jane admin privileges, and then after we have that, the admin panel will be visible for her when she logs in. You can also archive and restore users, so if someone leaves the company and you'd like to restrict their access to the server through the admin panel, you can set them to archived. So Jane's able to log in normally here, but we're going to archive her, so she will not have access anymore. And next time she goes to log in, she'll get an error message, and any request that she sends to the server will be rejected. So we don't want to just straight up delete her because her user ID might be associated with streams or projects or other information. So rather than remove the user, we just set their permissions so that they can't do anything at all. A couple months later, Jane decides to come back, we can restore that user and her access will be restored. Editing users' privileges. Also, you can bulk archive or restore streams. So any of you who are running servers will know streams pile up quickly. It can be overwhelming for users in their streams tab. There's a ton of them. You can quickly deactivate those so that they'll no longer show up in searches through the UI. They're still on the server, they just won't show up for people who are searching for them. And also as an admin, you can edit any stream. So let's say, again, somebody has left the company or moved on or is unresponsive and you need to make an edit, say add a user to a project. You can navigate to that stream from the admin tab and then add users or change stream properties as needed, assign it to a project, etc. You have a similar set of capabilities for projects. So go to the project page, let's filter to find new guy's project, and I'm going to add myself to it here. So again, if you're not added to this project, you typically wouldn't be able to edit it, but through the admin panel, you're able to access this root. And then one other thing that, these have all been improvements to the web interface, but we're also doing some improvements to the Grasshopper client. So here we're able to assign streams to a project from the Grasshopper client. So let's say we have a bunch of different streams all related to the same building project. Here they're mass, grid, columns, floors. We want to associate all of those with a project called demo project. We can do that here. And then next when we go to look at that project, it will have shown up here. So we quickly load that up in the view if we want to get an overview or share an overview of the project. And then finally, something completely unrelated, although a little bit related. We're talking about plugins for admin. So I've been working recently, and this will be merged into the Speckle Admin master branch soon. The ability to dynamically register components for the front end. Sharing is great, and open source is fantastic. Sometimes we need to write a piece of software or an extension for Speckle Admin that is specific to your company's workflow, or for other reasons needs to stay private. We'd like to do that, though, in a way that still takes advantage of all the great things that are in Speckle Admin, so the authorization flow, the viewer, etc. So luckily, Speckle is built using another open source project, Webpack, that allows us to look at a folder within our Speckle Admin project and add components dynamically as we're building it for production. So we can also then add those components to the roots within our Speckle Admin viewer or web client, so that we can add plugins that live in a separate repo, something that's not shared publicly, pull them to our Speckle Admin project, npm build, and then they'll be added. So you can see here, got a little demo one that we're working on at Woods Bagot. We have a separate list of projects that lives on another server, and we want to be able to sync those projects from called DI Portal. We want to be able to sync them back to Speckle. So got a little thing to make sure that projects have been synced. So in this, the Woods Bagot Admin Tools is a plugin that we're able to add to Speckle Admin while keeping that code not shared publicly. So, again, that's all I've got. I just wanted to say thanks again to Dimitrie and Matteo for having me. Trying to keep this pretty quick because I know we're running a little bit late, but thanks again. If anybody has any questions on any of this stuff, I'm available on Slack, the Speckle channel. Thanks again.
Thanks, Matthew. Matthew did other stuff like making the viewer look better, opacity going properly, some shadows and stuff. And actually the extra admin plugins that we've been, could have merged it, Matthew. I think it was ready pretty much now. Anyway, Matthew's not here anymore. But Matthew's kind of sorting out half of my to-do list, which is great. Because, yeah, anyway, quite a bit of stuff we need to do. Next one up is Izzy, if I'm not mistaken, who used to work at Arup. So come on, don't be shy. You'll have to take the mic while I figure out how to share your presentation again. Yeah. I copied it on... Oh. I hope I copied it. Let's see. No. Easy. There we go. It worked. There you go. It's all yours.
Cool, cool. It'll come up?
Ah.
Do I need to do something?
No, I need to do something. It's deep. Desktop. Are we okay, Matteo?
Yeah.
Yeah? Cool. That's good.
Cool. So hi, I'm Izzy. I'm a mechanical engineering student at the University of Edinburgh, and I'll be talking about a quick and dirty example MEP workflow that we did for a hackathon back in February. So the goal of this example workflow was basically how could we get from a design brief to a final-ish report in a semi-automated and pretty efficient way. So this was a collaboration between 3 different engineers, so we were all working in different offices, and we were all using our own preferred software platforms. So the main goal here was to kind of demonstrate how we could all collaborate on a single project and maintain this single source of truth for the project data while all using the different software tools that we prefer to use. So here is, there is the workflow diagram. It's going to be unfortunate, but it can be sort of split into basically 3 different sections. So getting the initial design information into Speckle, doing the calculations that we want to do. So we did ventilation, room loads, and HU sizing. And then the final step was just pulling it all together by pushing all the final data into Revit and then compiling a report. And as you can see, Speckle was sort of the connection between all of these, holding all our project data and our calculation results. So let me just show you how we did it. So these are all videos, so I hope this...
It's very laggy because...
Okay, well, my presentation is all videos, so this is going to be awkward. But this is the first stage. Here, Tom, the first collaborator, was just simply copying and pasting our design data or design brief data from an Excel spreadsheet into the Speckle. This is the old Speckle UI. Ignore this. And then emailing the rest of us the link. So, if you don't know Speckle, you can store all your data in different streams and then collect them into a single project. So what we did was have a single project for all our Speckle streams that we were using for this example workflow. So the next step was getting design data from Revit. So here I'm using a Dynamo script, and what I'm doing here is just pulling out all the room geometry information, like the name, height, floor area, perimeter, other stuff like that out of the Revit model, and then into a new Speckle stream added to our project. And then now for the calculations. So this first one is not what I wanted. Oh! So this first calculation was the ventilation calcs. So here Tom has a Grasshopper script that he's put together that does the whole calculation for us. And then so all he has to do is pull in that initial design brief stream and then the room geometry stream that I just created. And then connect it all up, and then at the end it'll push the results from this calculation into a new Speckle stream in our project.
It's getting there.
It's coming along. So here I'm doing basically a very similar thing, but I prefer to use Python, so I have this Python script here that was doing the sensible, latent, fabric, all the different room gains based on the initial design data stream and then the geometry stream that I created earlier, and then just does all the calculations here and then pushes it to a new stream in our project so everyone else has access to it. It would go there if this video played. We'll just move on. And then here, the last calculation was David's AHU sizing. So here he's using Dynamo, and he's using these custom components that are exposing this internal Arup calculation tools called Design Check. But basically, he's just running all the calculations within this custom Dynamo script and then pushing the results to a final calculation Speckle stream. And then, now that we've all got all the calculations, this last bit is just tying it all together. So here, I'm taking those load calculations that we did earlier, and I'm using Dynamo to push them back into the Revit model so they populate the parameters for each of the spaces, or the corresponding spaces in the model.
If you move the mouse, it might actually trigger it.
You have to click play maybe at the bottom.
Play, yeah.
Is it?
I can have it.
There are two different slides. Is it?
It's moving.
Okay, well this is the final step. So here we're just picking up all the streams that we've created, so all the input streams and then the resulting calculation streams, and then I'm using this Python script to compile that all into this report template that is produced in this nice PDF here. It sort of showed up. Well, if you would like to see this video in more than 2 frames a second, the link is up in the corner over there. So have a look at that because you only saw about half of that. But anyway, here's the workflow diagram again, just to remind you. So basically, if that video had played correctly, you would have seen how we were able to get from design brief data to a finished report in about 5 minutes of actual work. So the video is about 5 minutes long, played at normal speed. So yeah, that's all for me. Check out the video.
Izzy's defense, we forced her to export her nice keynote presentation to PowerPoint just before this presentation. So, but I hope for me this is quite interesting. This was the first cool workflow that I saw when I joined Arup. It was pretty much coming from Izzy and Tom. Now, next one up is Mish, if you're still awake. Please. Mish is, he's from Toronto. And he actually did most of the development work for the past 6 months. This is no pun intended, even though he's not working for Arup anymore since 2 months, or 3 months. He joined us over summer from Toronto, and he probably developed quite, I mean, he put Matteo and me to shame. Let's just leave it at that, okay?
Okay. Thanks for that introduction, Dimitrie. So, my name's Mish. I worked at Arup for a year as an intern, started off as a structural intern, and then moved to the digital development team here in London. And right now I'm a student at University of Toronto. So just to preface this, most of my presentations also in the form of a video. So, and unlike Izzy, I didn't have the foresight to publish this online. So if anyone would like to have a clear picture afterwards, I'll share it somehow. So I'll be going over 4 separate products or aspects of Speckle which I've developed. Firstly, the Speckle JSA component, which connects JSA to Speckle. Secondly, Speckle Excel, which takes data in and out for Excel. And then 2 kind of new development called Speckle Manager and Speckle Processor, which I'll go into more detail later. So firstly, Speckle JSA. For those who are unaware, JSA is a structural analysis program developed by Oasis within Arup. And the Speckle JSA plugin is able to translate data from Speckle into JSA. And the types of data you're able to transfer includes geometry, loading, properties, results, essentially everything that's required to create and run a model and extract it for further use. So let's jump right into some videos. So here on the left, we have a Grasshopper script that is creating a structure. We apply to it various loadings, various properties to it, and we're able to transfer it directly into JSA using the Speckle JSA client. And every single thing is translated properly, so you're able to run the model right from the bat without any further modifications. So here's just the video showing the analysis being performed and the analysis results being displayed. Just give it a sec. Okay, let's move on. The next plugin, the next workflow that I would like to show you guys is the Revit into JSA transfer. So Revit has an analytical model which contains data regarding the structural model, and using the Speckle Revit plugin, we're able to take the data about the structural form to Speckle and translate that into JSA. So as you can see, the model is directly transferred and you're able to run it straight off. I'm performing some slight modifications to make the model run faster for the demo purposes. But at the end of this, you're able to view the results and display it. Now on the other side, taking data out of GSA, we have that same model that we've analyzed, and I've created a stream and displayed it on the online web viewer. And every single result that you wish to embed into the objects are embedded, so you're able to display a contour, for example, of the moments within the slab and share that result and viewing to other people without having to share an entire model that may be a few gigabytes sometimes. So that's pretty much a quick overview of the Speckle JSA client. It's available now through Oasis if you would like to grab a copy. Yeah. So next.
It's free to anybody who's got a JSA license.
So next, Speckle Excel. Essentially what it does is it takes all your stream data, which is essentially a JSON, and translate that into your Excel sheets as a representation in a tabular format. It's still in early development, but for example, what you can do is you can create an object per row. In this case, I created a point, a line, a polyline, and a mesh in Excel, put in all the data regarding the coordinates, and now I've pushed it into Rhino without going through Grasshopper, and now I can control Rhino through Excel. So if I really hate Grasshopper, I can skip that step. I don't hate Grasshopper, by the way. So as you can see, you can change any of the data within Excel, and you can push that, and when it's received into Rhino, all those changes are captured. Okay. Now, going the other way, from Rhino and Grasshopper into Excel, let's say I want to create a bunch of random numbers using the Grasshopper component. I can take all those random numbers, send them through Speckle, receive them in Speckle Excel, and create a histogram. So any changes in the random data that I've introduced is reflected. Obviously, this is a pretty trivial example using random data, but you can imagine this is very useful, especially when you have objects with a lot of complex data embedded into it, and being able to put it into Excel and leverage a lot of the design calculations that has historically existed within Excel in the engineering world. So it's still pretty early works, and it's still in development, but hopefully it's going to be released soon. Officially, it's going to be supported for Excel in Mac and Windows, and also Excel Online. The GitHub repo is right there. You can actually download it and sideload the app by yourself and play around with it if you wish. So Speckle Manager. Speckle Manager is a desktop application that does three things. Firstly, it allows you to manage your accounts on your desktop. Secondly, it allows you to install and update plugins. And thirdly, it allows you to install and update kits. So the current method for installing Speckle plugins within your desktop is by installing the large installer and running the exe file. So what Speckle Manager allows you to do is it allows you to select specific components that you wish to download. For example, Speckle Dynamo or Speckle Rhino individually, and install them. And this is all pulled directly from the GitHub repo. So you're able to be notified whenever a new release is pushed out by the developer, and you're also able to switch between different versions of the releases. In addition, if a company or team has a specific or custom add-in that you wish to install, you can just add it to the list of repos for the desktop app to search through, and it'll add it to the list, so you're able to install that. So, Speckle Manager, no timeline. It's pretty early days for it, proof of concept, but if you like to play around with it, it's again on the Speckle Works GitHub page. Lastly, Speckle Processor. So the Speckle Processor is a part of the Speckle admin page, and it's mostly a proof of concept, but what it does is it takes a stream as an input, runs it through several functions, and all those functions can link into each other and provides the input for the next. And at the end, this is all packaged as a stream. So this may be a bit confusing, so let's go through an example. Let's say I got a stream that's a 10 by 10 by 10 grid of boxes from somebody, and I'm only concerned about the boxes in a specific region within this vicinity, and I don't want to download all the objects. So Speckle Processor can do that straight from the Speckle admin. So the first step, what it does is it downloads the stream, and then it applies a proximity filter based on a point you specify and the proximity to it, and re-uploads it and repackage it as a stream. And all these separate blocks are different functions that you can stack on top of each other, and you can create custom functions within your own Speckle admin deployment. Cool. So a more complex example, let's say I have this stream now, which is a series of boxes, and there's this cool API that generates a random number, and I want to embed random numbers into every single one of my boxes. I can do that with Speckle Processor. So again, I download the stream, then I call the REST API with every single object and embed the result into the object itself and publish it as a stream. So now every single one of my boxes has a property that's a random number. Within the UI, you can actually inspect every single object and output at each step, so you can debug it along the way. Now for a more fun example, let's say you have a stream that contains all of your MEP data, and it comes from Revit, and your team has a design calculation platform that you want to run this through so that you don't have to go through Excel and run all your calculations again. So that's exactly what you can do with with Processor. So this is leveraging Arup Compute, which is a REST API platform for design calculations within Arup. And through Processor, you're able to download all the objects, run it through the design calculation platform and using the REST API, and then embed the results within the object itself. So that's Speckle Processor. The proof of concept's already deployed on the Speckle admin within app.speckle.systems. You may have seen a little tab right below the viewer tab called Processor. Feel free to check it out. Yeah, play around with it. That pretty much concludes my presentation. So, thank you.
So you can see why we're ashamed we didn't do half as much in the same period of time that Mishael was here. And Processor is quite cool because, besides just attaching random numbers, you can see there's doing checks or codifying your own kind of logic and embedding it into Speckle streams. Anyway, now next one up is Poinet. Where is Paul? Oh, there is Paul. Who's going to talk about yet another kind of enhancement or addition that is pretty much could be essentially a whole research project in itself. Actually kind of is, partly. Specifically Speckle Viz, which is visualizing the data flow within the Speckle world. So.
Exactly. Thank you for the introduction. Thanks for staying so late. I'm a researcher at the University College London at the Bartlett School of Construction and Project Management. Here is about the contents of the presentation. So first a bit of context and precedence, so what led to Speckle Viz. Then part about what in the Speckle API allows you to do such interface, then interface itself, and then a case study where the interface is developed. So for the context, I work at UCR, part of the AEC Delta Mobility Grants, which is Innovate UK funded, and it's an 18-month project which started in February 2019. There are different companies involved, mainly Bureau Uphold and 3D Repo. You can find most of the information of the AEC Delta's projects on this website, github.io. And what we are trying to ask the question: how do we share information today, and how can we improve that? So today, the traditional workflow, you have a big file, and then you make one small change, and then you're gonna export this file again to someone with all the data and with this change. So we would like to break this down into different parts and only focusing on the bits that change in the design process. And also, how do we keep track about the data flow through different users through the projects. Obviously, that's not a new problem. It has been tackled by different individuals, both in academia and industry. So I will go through that quite fast chronologically. So this is Book de Vries in 1995, activity network diagram between different companies. The thesis of Oliver Tessman that identified design cycles. He called it in the design process, in the building process in 2007, 2011. Design to production. They are a company based in Switzerland, and they do all the rationalization for complex freeform T-bar structures. So how the data flowed from the earlier stages to the later stages. Sharp Architects in 2012. Boxes and Arrows again. Gary Technologies, now Trimble Consulting, 2013. fronting in 2015, they tried to map all the data flow between different Grasshopper definition where they could generate the data and Rhino files where they could store the data, and that allowed them to sustain the design process for the Morpheus Hotel in Macau. With Bagot, in 2017, they generate this graph based on the data exchange in flux between different Grasshopper, Dynamo, and Revit files. So this is confusing for everyone. We have a lot of boxes and arrows, and yeah, it's quite complex, and we're all trying to solve this. So Speckle Viz tries to address the same issue in Speckle. So what is Speckle? No, I'm just kidding. So I will focus here on the Speckle clients. They help you basically to track the data connectivity and dependencies through the design process. So each time you generate a Grasshopper component or a Dynamo nodes in Dynamo, it will know, Speckle will know when and where it has been created. This has been presented before, I think, but if you go on the AMI interface on a page of a stream, you can have information about the source and the receivers. That's a screenshot from the API itself, so you can see that you have a sender and a receiver with the specific IDs. So from that, you can start to map, you can start to map a graph of this information. And obviously that's a simple one, just with two, but the design process is more complex, there's more people involved, and much more different platforms, as you've seen also with Mishael's presentation. Also different documents. So here it is, so you have two Grasshopper components, you can have two nodes. If I knew it was so laggy, I wouldn't have done all these transitions in PowerPoint, but yeah, you have a sender and receiver here, then you can insert, I inserted these third nodes. Some people think it's confusing, but I think it might be important actually, which is the stream itself. Then you have you might have multiple receivers. That's not exposed in Speckle, but also you might have multiple senders. So I mean, right now I know that you cannot send data to a stream that has been previously generated, but I think in the future that may be possible. You also have different documents in which these senders and receivers exist, and you have also different users, and all this can actually overlap, so that's quite of a challenge to represent all this complexity. So Speckle is where it's located. It's located at the bottom. Sorry, my bad. Of the project page in Speckle. So it's hidden at the bottom after where all the streams are listed. So it's there. That's how it looks like. So on the top part you have the control area where you have a toolbar, a time range slider, and you can also do some queries by tags because each stream contains, you can assign tags to each stream in Speckle. And on the bottom, the graph canvas. So, well, I know it's a mistake that I used emojis because everybody only looks at them, not at the graph itself. But this is a legend, and I use them because it was easy to implement. You have the rocket for the Speckle sender, the satellite antenna for the receiver, the satellite itself for the stream, and the dots are also like Grasshopper for Grasshopper, a range for Dynamo, don't ask me why, a Rhino for Rhino, and Diamond for Oasis, don't ask me why as well. And it's color-coded by time, so all the gray stuff is old, all the purple stuff is new. Then you have the clusters. You can either cluster your graph by documents or per user. So on the left you can see that it's a Grasshopper document in which you have two receivers and one sender. On the right, that's me from Mishael, who generated 5 receivers and 3 senders. And all the rest of the presentation is a lot of videos as well, but so it might be awkward, but this shows that for the same graph, for a specific project, you can switch the view between the data flow per document or the data flow per user. I mean, you can zoom and zoom out on this interface. If it's lost, you have a button that can refocus the graph. You can expand and collapse the nodes because that might bring you more clarity to the graph. You can always right-click on a stream and inspect it in the viewer. You can play with a time frame slider, so if you want to focus on a particular time range, you can do it, and then all the streams gonna be aggregated on that bottom over there, so you can click on it and it will aggregate all the streams from this time range in the viewer. You have a button for refreshing the graph because sometimes you add streams to your project, so the graph won't automatically update, so you can do it manually. If it's too bouncy, you can always fix the graph. Yeah, it's not really important anyway. You can you can query the streams by tags. Actually, that was an idea that was introduced by Grimshaw architects. Because so like the idea is like to transform this simple visualization into a more like management platform where you can select the tag, you know, by streams, and then they will always be aggregated, and you can check them in the viewer as well. And as you may know, in Speckle you have much more properties than tags. So this was an experiment with power coordinate where you can select like all the properties that are exposed. So when it was created, when it was updated, the units, the tolerance, the object numbers, and then on the bottom on the graph, it will show you the streams which have all these like common properties. And then here's a small case study because obviously like it's always hard to find building data, even in these grants. It's hard to get because of IP reasons to get real project data. So I use a workshop I did with some colleagues last year. So we are two persons. I work in London. My colleague is an engineer working in Brussels. And this is the data flow between us two. That's the same data flow between different Grasshopper definitions. Well, again, you can switch between different modes. And that shows you the two data flow per, the bottom one is per files, the one on the right is per users. And here I'm going through each stream. So if you can follow on both graphs the streams that are selected, well, that's the same for both graph, right? So you go from the abstract network to the most refined mesh, and it goes on until the data for fabrication. So that summarizes all of it. Yeah, that's a video showing the same thing again, but I will skip that. And then we have a super secret consultant working in Arup. I mean, I'm just showing this because it was only two persons. I mean, you only saw the graph with 2 persons, but obviously you can add as many users as you want. So just to show you that it can be scaled up and you can involve you know, many persons in your project, and you will continuously see the data flow. Yeah, I will end up with this. Yeah, it's kind of funny to see it appear laggy. A lot of people, when I show that, they tell me it's a blockchain, and no, it's not a blockchain. As far as I know, there is no blockchain inside Speckle, so yeah. If you want to test Speckle this, well, it's on the main branch now, so same address, appspeckle.system. And all the docs, all the GIFs that were super laggy so far, you can find them all on the main website. So thank you. And also, if any one of you in the room has interesting case studies that could be deployed in the graph and could be presented, we would be interested. Yeah. Thank you.
Thank you, Paul. This is really cool work. I'm happy we finally merged it. Now, our last presentation, and then after we go out for drinks, okay? I mean, we actually have drinks waiting for us outside. So next up, they flew all the way from Rotterdam, Pieter and Marijn from Royal Haskoning. Please.
Hello.
I will now fiddle with the thing, okay? So let's hope it works. That's good. It was on the USB. Yeah.
The top
this one.
Yeah, that one.
Cool.
Just to be clear, does this work without a microphone as well?
It might work for the live streaming, but we have another mic. I'm just going to bring
that's maybe easiest.
Okay.
Maybe then I get started already. Hello, my name is Pieter Schreurs. I'm an architect and computational designer working at Royal Haskoning DHV. We're a Dutch design and engineering consultancy of about 7,000 people. So relatively big company. We're also located here in London. We have an office here. So I think there might be one of our colleagues here as well in the room, but I'm not sure if he's here. Doesn't matter. So we are basically going to present a small case study on a project that we have done implementing Speckle. And Marijn is...
Yeah, my name is Marijn.
Yeah.
I'm based in the Amsterdam office of Royal Haskoning DHV. I'm not sure if you're aware, but my club is playing right now and they're doing good. I is playing the Champions League.
Yeah, so we're going to do a presentation about a different football club, right?
Yeah.
So that's the...
Yeah, that's true. So we're actually going to do a presentation about our rival club stadium.
Oh, it's really so. Yeah.
Oh, it is.
Last presentation, and I'm still not aware of this. Okay, so we're going to present you a case study on the Feyenoord Stadium. This is a football stadium in Rotterdam, which has been recently designed by OMA, the architectural office of Ruim Koolhaas. I assume you all know. And we have done the structural design of the stadium, and we have recently finalized the final design of the stadium. And our role in the what I've done in the project. So in this project, which is a large-scale project with a multidisciplinary team and different stakeholders, we had a lot of concerns to deal with and to integrate into the design. So we were really in need of a way of interoperating between these different stakeholders. So that's why we decided to start implementing Speckle. Actually, before Speckle was even available to us, we were already experimenting with trying to exchange data between the different software packages we were using. Here you see diagrams of different stakeholders. In the center you see actually the coordination model that we have created, from which we have driven all the different concerns and provided the other disciplines with data. So on the right hand side you see the construction, the structural engineer. On the left hand side you see the architectural model of OMA. We also generated a model for MEP, which was one of the disciplines involved on our side, and also a model to do CFD analysis. This was all driven from one parametric model. So what we set out to do was incorporating the requirements and guidelines from the FIFA and UEFA, and these were driving actually how we would build up the design for the stadium. And OMA didn't have any parametric designers on the project, and they really wanted to make sure that the design that would be made would fit these requirements. So actually we as Royal Haskoning DHV provided them with our expertise to actually incorporate this into a parametric model. And the key parameters here are actually, come up next, well, actually the perimeter of the stadium, where all the seats needed to be within a certain range from each corner flag to be counted in the seat count, so that we would actually get a 60,000 seater stadium. And the other important parameter for the UEFA was actually the C value, as they call it, which is actually the clearance you have over the head of the person sitting in front of you, so you can actually properly see the field. And then we also had more soft constraints or more architectural constraints that we needed to incorporate into this model, which was actually that OMA was keen on capturing the atmosphere of the old stadium. There was a lot of fuzz going about a new stadium being built, and of course the supporters were very keen on their existing stadium, and they wanted to really capture the atmosphere of that. So somehow we needed to also work this into the model. And what we decided to do is actually to try and get this perfect bowl shape and realized that within the constraints that were more hard, that were given by UEFA and FIFA. So we set up a parametric model in which we can actually evaluate the C values and make sure it's always within the given footprint or the given constraints from the field. And then we could optimize our C value while still maintaining this nice oval shape and a continuing ring shape, and dealing with the parameters to get an optimized stadium structure. So yeah, this is sort of a straightforward implementation of Grasshopper in an architectural design project, I would say. But what we did from here was actually setting up a coordination model that would define the outlines of our structural layout and defining the grid lines that we would require to actually start setting up a structural model from here. And then we started using Speckle actually to exchange between the different Grasshopper models. So we went from this coordination model into a structural engineering workflow, which was in a separate Grasshopper file. This is also a movie, so that's going to be good fun.
Really nice. I can pause it, right?
Yeah, I think so.
Then it will. There it is. We have from this coordination model as a basis, which we kept as a basis throughout the project. We built up two different structural models. One of the tiers, which we see here, where we have a lot of steel members and some concrete cores. And let's see if I'll put it on pause at some interesting. Try to put it on pause on some interesting stuff.
Yeah, that's going to be difficult, I guess.
So we built our structural models in Grasshopper. Created our Karamba models and used Karamba in Grasshopper to actually optimize all our structural beam members and the layout of the structure. And next to that, we had this for the tiers. We also had a separate model for the roof, where we had all kinds of different variants we had to evaluate and design. And these, of course, were connected. So this was at the first part where Speckle didn't exist yet. So we started tinkering with our own little JSON schemas and creating our objects. So we were very happy that you guys then started Speckle. Because before we were actually using Flux by Google, who, of course, I guess a lot of you also know, stopped, and we were in panic. So we started building our own stuff, and then you guys did that a lot better. So we could use that. And then from these structural models we had a couple of different variants we calculated, and we actually created a plugin that from our Karamba model generated a JSON schema that was then we were able to translate to a lot of different FEM packages, which was also great because we could validate a lot of the calculations that were being done in Karamba. And we actually used this base Grasshopper model as a basis for all the engineering analyses that were done.
Yeah. So we were already developing some software in-house, and we had our own structural object model basically in place at that point. So we implemented our own code, and we implemented that on top of Speckle basically. And that's where we started using, that's where we were able to actually connect even more software packages. For now, this is in-house development only, but we have to see where this goes. Also, we have to connect it to the now existing structural model in Speckle as well. So that's actually the next step that's on our roadmap to develop on. So from the information we accumulated in our structural design analysis, we actually were able to generate our BIM model immediately. This is also a workflow that we have been seeing already a lot tonight. But at that point, well, to be able to actually get the structural members in the right position in Revit, we did require a Dynamo script to actually make sure that everything would end up in the right place, and actually to deal with the different concerns that we have in a structural model with regards than we have in the BIM model. To be able to calculate, we had modeled initially all the members based on their center lines, the reference lines, and make sure that they intersect in the nodes, and then we can easily calculate from that. But that was the information that we had, and then we had to generate the BIM model from that. So actually we needed Dynamo to make sure that we positioned all the members correctly. So what we found is that in this interoperable workflows, we actually need to accommodate for these kind of different concerns that you might have in different models. So this is also something that we have to get processes in place within the company or within how we work, but maybe also there are opportunities for automation here. And I think, for example, the processors would be very interesting also to see if we can use it for these kind of use cases as well, that we can actually reposition and make sure that we deal with the different concerns in the software. And the other thing that we notice is that actually our BIM modelers, so the people who are normally in charge of making the BIM model and also are responsible for whatever is the result in that BIM model, found it really difficult to deal with generated models, because basically we kept iterating and there were design changes all the time, and then we generated a model, and then 5 minutes before deadline there would be a new model, so to speak. So we also need to consider how to deal with that also with regards to responsibilities and how we can have people work with these new tools and information generated on the fly. So they actually need to be able to do their work properly and also to validate whatever has been generated. Of course, here there's also opportunity for automation, but also for user interaction that maybe could be developed in the future. So eventually, it's going to pop up at some point, I guess, or it's going to, half video. Yeah, so in the end, we ended up with a completely collated BIM model with all these structural members nicely in place, based on the workflow we set up with Speckle in it. So basically we had all different clients running. So we had the Grasshopper model. Basically we used the Speckle client actually to get this into the server, into the Speckle server. We generalized it in this image, but actually this was the Speckle server, Speckle API with the Mongo database behind it. At the Grasshopper model we used the Grasshopper client as well, but then actually for our BIM concerns and for our structural models we used our proprietary software that we had developed. And we all made that tab into the same API actually. I have a small diagram of that in the next. So what we did on the base of the Speckle server, we actually implemented Speckle where we had the Grasshopper models or the plugins that were in place at that point. And we used our own RHDG FEM implementation actually to deal with Karamba and also the structural analysis software and eventually generate our BIM model from that. Both in Revit and in IFC, we actually had code in place to generate the IFCs also on the fly, and that's how we implemented this whole workflow within this project. So we have been developing quite a lot on Speckle and around Speckle, and we have a roadmap also to develop on that. Oh, yes, sorry. So I'm just I can just sit down. Wait, my bad. We had agreed that he would take over again.
I would do the last two slides as well, but that's fine. So actually the roadmap we envisioned, we were talking about this yesterday, and where is the first things we were going to go and what are the things that we now think are lacking. And actually a lot of these that we're now going to talk about, we've seen already some really, really nice solutions to that tonight, so we're already very happy that we came. One of the main subjects was integration in a field, in a couple of fields. We wanted to integrate it into our own company, and that also means for us to have our own front-ending and our own corporate identity on it. Too bad, but that's something that people, what value? They value.
Value, yeah.
We were already mocking up a bit of a view app our own. This is something we'd like to be able to incorporate. We were thinking about, there are in a lot of engineering companies, also in ours, there are a lot of own toolings being created and own APIs being coded. And we would, of course, like to be able to have a standard workflow to incorporate these in our admin. And this is just a small mock-up of a base of design app we're creating. And we would like a standardized workflow to incorporate these in the admin app. And that is, of course, what we've seen earlier on for the plugins as well. So that was really cool. Then automation, where we've also seen a lot about with the processors now already, which is also really nice. That's something that we're talking about a lot, and we've seen now during the presentation, Pieter and I looked at each other quite often thinking, well, this is kind of what we're looking for, so that's good. So automating and handling our streams automated on the in the cloud, so people that are actually receiving the data only receive it the way they need it and don't have to do anything for that. And then we have some extended authentication and user management, being that we envision us to work with our clients or with other parties together in one cloud environment. And you might not always want to share everything you do in a project, so have like a deployment branch where you can share stuff with your clients, and have a development branch as well.
So yeah, I think to conclude, we're also, as a community, very much on the same lines, because actually the requirements that we have just described, I think, were captured in a lot of the presentation already that we've seen. So I would like to see where it goes, and now we keep this moving forward. And it seems that Speckle is broadening really as a platform also to be able to incorporate more and more of these things. So yeah, I think that's it.
Yeah,
thanks.
So thank you very much.
Thank you. We were joking, Matteo was jokingly saying that we didn't show a roadmap, but you did show a roadmap for us. So there you go. There's a specific reason we didn't show a roadmap. That's because we're planning to have more drinks tonight. So this was the last presentation. Thank you. It was really cool to see what you guys did. And I'm happy that it worked out, that you saw other stuff. That was the point of this evening, after all, essentially. Open up some boxes and show some stuff, because we've been quite really bad at... We've been doing stuff, but not necessarily announcing it right, or we've been announcing it on Twitter, expecting everyone's on Twitter, but not everyone's on Twitter. Anyway, there's more drinks outside, so let's all enjoy the evening. Okay? Cool.